Rolle's theorem and mean value theorem homework help. My students recently were given an assignment, a homework assignment, over Rolle's theorem and mean value theorem problems. I wanted to work out one of each in this short video to give some assistance. Okay, for the exercise below, determine whether Rolle's theorem can be applied to the function in the indicated interval. If Rolle's theorem can be applied, find all values of x that satisfy Rolle's theorem. Well, the main condition for Rolle's theorem is this, that f of b is equal to f of a. In this case, our assigned value over this closed interval from 5 to 6 is a will be the 5 and b will be the 6. And so we're going to say, I'm going to go with the left here, f of b, well, b being 6, is going to equal, we're going to substitute in 6 in place of x. So 6 squared minus 11 times 6 plus 30. And we get 36, 6 squared, 36, minus 11 times 6, which would be minus 66, plus 30. And combining our 36 plus 30, we're going to have 66 minus 66, which equals 0. Okay, now let's try f of a, which is going to be f of 5 equals 5 squared minus 11 times 5 plus 30. And we're going to get 25 minus 11 times 5 minus 55 plus 30. Well, 30 plus 25 is 55, so we have 55 minus 55 equals 0. So we do have f of b equals f of a equals 0. So therefore, Rolle's theorem applies. Okay, next we're going to go ahead and work this out, and for that we're going to need to take f prime of x. So we take f of x and differentiate it, and we say f prime of x is going to be x squared becomes 2x, and minus 11x differentiated is going to be minus 11. And we're going to set our average rate of change is going to be 0. That's Rolle's theorem. So we replace f of x with 0. And so we have 0 equals 2x minus 11. And solving for x, if we add 11 to both sides of this equation, we get 2x is equal to 11. Dividing by 2, we have x is equal to 11 halves, or in decimalized form, 5.5. And so, is this a value between 5 and 6? Yes. So we say that at x equals 5.5. Let's see, how do we say this? Instantaneous rate of change. So f prime of x is equal to 0, or a horizontal tangent line. So that is our value of c that makes this work. So let's go ahead and box this one. Okay, next we're going to go to a mean value theorem problem for the exercise below. apply the mean value theorem to f of x on the indicated interval, find all values of c which satisfy the mean value theorem. And so for that, we're going to find f of b and f of a. Again, we have a is 1/2 and b is 2. So f of b is going to be f of 2. And substituting in 2, we have 2 in place of x plus 2 over 2 is equal to 4 over 2, which equals 2. Next, f of a. Well, a is going to be 1/2, so f of 1/2, we say, is, in the place of x, 1/2 plus 2 over 1/2. And for that, let's see, 1/2 plus 2 is going to be 5/2 divided by 1/2. And dividing by a fraction is the same as multiplying by its reciprocal. So this is going to be equal to 5/2 divided by 1/2 is 5/2 times 2 over 1, which equals 5. So that's going to be f of a. So our average rate of change is going to be, let's say a rock equals f of b minus f of a over b minus a. In this case, we have f of b is 2, and f of a is 5, so 2 minus 5 over b minus a, so we have 2 minus 1/2. And this is going to simplify to 3, negative 3 in the numerator. In the denominator, we have 2 minus 1/2, so that's going to be 3/2. And this is going to be equal to negative 3 times 2 over 3. And canceling out here, we have negative 2 is going to be what our A rock is. So next, what we're going to do is we're going to set negative 2, our A rock, equal to the derivative of this function here. Well, first of all, what I'm going to do is we're going to rewrite f of x. So f of x is equal to x plus 2 over x, so it simplifies to x over x plus 2 over x, which simplifies to 1 plus 2x to the negative 1 power. So that's going to be our f of x, and f prime of x is going to be the derivative of this, so the derivative of 1 is 0, and so for the second term here, we're going to bring negative 1 out front times 2 x to the negative 2 power, which is going to equal negative 2 over x squared. And so what we can do is, using the mean value theorem, our calculated A rock is negative 2. So we say negative 2, which is A rock, equals negative 2 over x squared. And we can multiply both sides of this equation by x squared. So we have negative 2 x squared is equal to negative 2, and we can divide both sides by negative 2, -2. Let me see here. 2 and -2. And so we have x squared equals 1. And so therefore x is going to be plus or minus 1. And looking back at our condition, between 1/2 and 2, the only value that qualifies is going to be between the positive version. So x is equal to 1. So 1 is the value of C where IROC, let's say instantaneous rate of change, equals the average rate of change. So that's going to be our answer using applying the mean value theorem. So I hope this is helpful. With the other problems, it's conceptually the same thing. So hope this helps again, and thanks for viewing.